So this one, your y dependent variable to be interpreted as percent. So meaning that when x, this one not linear. So when increase one unit, when x, this one double log. This one log linear. So you see that when x increase one unit, then y increase or decrease by how many percent? Beta 1%. Okay, beta 1 times 100%. You have to multiply lah. Beta 1 times 100%. So when x increase 1 unit, not percent. X increase 1 unit, not percent. And then y will increase or decrease, depends on positive or negative. Increase or decrease by beta 1 times 100%. Okay. For the case of if you have linear log model, linear log. This is linear log. This is log linear. This one log linear. This one also the same. I forgot to put the arithmetic. You can add the arithmetic. This one. So the example I give just now, if you want to model the effects of income on consumption, then linear log model is the best, the most suitable form of regression model. Okay, to represent the effects of income on consumption. So in this case, you see that the slope. Oh, I also forgot the beta 1 to put beta 1 as well. So here is a beta 0 plus beta 1 log x. Understand this one? So this one y equal to beta 0 plus beta 1 log x plus error. You can fix it. It has beta 1, forgot to put. This one producer, So this one, if you use this model, meaning that the data, the dependent variable using ordinal values, but the independent variable you transform using log. And then in terms of interpretation, remember the slope, the estimate of the slope parameter beta 1, it represents the amount of change or the amount of absolute change in y per 1%. Sorry, this one gives a relative change. This one is equivalent, the difference between two values of x gives us relative change in x. If you want to interpret this as percent, you multiply 100 here. You multiply, but the whole coefficient, you have to divide by 100. Because only the lower part. Understand? Denominator here, numerator here, denominator. So this one, ordinal values. So give us the amount of change in y per relative change in x. But the relative change in 1 to 20%, you have to multiply this part 100. But the whole part, you have to divide 100. It's just like times 1 over 100. Okay. If you want to interpret as percent, then you have the estimated value of coefficient beta 1, the estimate of beta 1 times 1 over 100, or you just divide by 100. Yeah. So in terms of interpretation, you see that, let's say y is consumption, x is income. In ringgit, for example, consumption in ringgit. So we have income representing for a group of people. So let's say that you collect data for a group of different people, so individuals that have different income, and then you see how much they spend as compared to the income, log of their income. So in terms of interpretation, you see that based on this model, you interpret. You say that when income increase 1%, because your independent variable is income, so income increase 1%, is 1% after you multiply. When income increase 1%, the consumption increase, let's say positive So increase by beta 1 divided by 100 lah, percent. Sorry, unit. Why we need to mention the original values unit, not percent. So when income increase 1%, consumption increase or decrease by beta estimate beta 1 hat divided by 100 ringgit. Not percent, but unit. Okay. So you have to be careful when you interpret. You not remember whether to multiply or divide. You have to understand this one. You understand this one, easy for you to remember whether you have to multiply 100 or not, or divide 100 or not, or you just use the original values. Okay. So depend whether you use double log model. Double log model, you can just use the estimate value as a direct estimate of electricity. So X percent, when X increase 1%, Y increase or decrease how many percent? That double log model. Log linear used for just like to expect growth. Example just now. When X increase 1 unit, let's say for if you do the rest against year, 1 year increase by how many year? 1 year, and then Y. The GNP will increase by that one log linear by how many percent? Y 1%. But one when X increase 1%, Y will increase or decrease by beta divided by 100 original values lah, unit. If ringgit lah, if dollar or it depends on. So for different example, now we have an estimate. So you open the data. So it is GNP. So just remember for if you do your research project, if you use log transformation, then in order to provide interpretation, you have to interpret as percent. So you have to correctly provide the correct way of interpretation. Okay, so this one we have our GMP data, but we don't have the time frame. We have to create lah. Okay, to create time frame, one way you can just go to quick generate series. Quick generate series. You can type T equal to this the asterisk. So trend plus 1. Yeah, too small. T trend plus 1. So plus 1, your time frame will start from 1. If you only put trend, it will start from 0. So we put plus 1, so they start from 1. So generate series by equation. T equal that one, that I add time plus 1. So okay, so you have this one. You click T. So you have a sequence of value 1, 2, 3 up to last 120. If you do not put plus 1, it starts from 0, 0, 1, 2, and so on. Yeah. So to estimate model, go to quick estimate equation. So we have this one, log of G and P, C and T. Okay, so you get same right, same estimate. But you have to properly, but again this one also it has autocorrelation problem, but we just ignore the problem first. We just assume that the model is okay, satisfy all the assumption, but later we discuss about the problem and how to remedy the problem. So again, in terms of interpretation, you say that when this is average of a growth rate, so then every year, on average, the GNP increase by, for every increase in year, so every year, on average, the growth, the GNP increased by 0.02 for 6 times 100%, right? Multiply 100, don't forget. Multiply 100. Otherwise, it gives us relative change is not percent. If you want to see as percent, you have to multiply by 100. Or alternatively, if you don't want to prepare the T, you can directly estimate, you can just put that one up. You can just put trend. So alternatively, you get the same result. Let's say you don't want to prepare your T first, you can just want to directly estimate, and then just put like this now. So instead of T, you just put trend plus 1, you get the same. You estimate. So we take half an hour break. We continue lecture except at 8, about 5 minutes. 5 minutes. So we do exercises. I think we'll show you the alternative way for that session 1, and then variation. Have a big question for you. So I think we have time. Okay, so 5 minutes.